One of the many reasons that lakehouse architectures are popular is that the amount of data we store always increases. And by treating storage and compute as distinct systems, we can address many of the problems on each side independently. If we've accumulated a lot of data in our data lake, chances are when we come to query it, we don't actually need all of it to answer our question. And typically, if we want faster queries, then you want to read less data. This is where we start to look at data skipping, and it's supported in a bunch of different ways across different databases, and many of them will have multiple ways to take advantage of data skipping. In a Delta table, one way to do data skipping is via partitioning and partition pruning. With partitioning, when data is stored, we break it up and store similar data together. For example, if we have a date in our data, we might partition the table by month so that all of the data for 1 month is stored in a single partition. If we then write a query with a filter for only 1 month, we can skip directly to the partition for that month and not read any other data. And that's partition pruning. Partition pruning support is here for ClickHouse, and it works with both Iceberg and Delta. We can see how it works using the Delta Lake table function. In my Unity catalog, I have a table here called NYC Delta Flat, which is a Delta table without partitioning. I also have a table here called NYC Delta Part, which is the exact same data partitioned by month. So let's see what the difference is when querying the two tables from ClickHouse. This is a simple aggregate query with a filter on pickup date for a single month, and I'm going to run it on my non-partitioned table first. So without partitioning, I'm scanning about 10.5 million rows and 160 megs of data. So let's try the same query on my partition table. So that scanned about 3 million rows and 50 megs of data, which is about a third of our unpartitioned table. The data in my test table really isn't big enough to see a particularly significant performance difference, and partitioning is a strategy that is really at its best when you have very large tables, probably something over the 1 terabyte mark, but you can already see the difference in scan size, and at very high volumes, that is going to translate into much faster queries.